Welcome back, students. In this class we continue exercise 11.3 question 6 and the chapter is Introduction to Trigonometry. So the question 6 here is, if ABC are the interior angles of a triangle ABC, then show that sine of B plus C by 2 is equal to cos A by 2. So what is the sum of interior angles of the triangle is A plus B plus C is equal to 180 degrees. So 180 degrees. Now, so we have to take this A plus B plus C. B plus C is equal to 180 minus A. 180 minus A. Now we have to apply sine on both sides. Here you have to apply on RHS and LHS. Sine B plus C and sine of 180 minus A. Then divide by 2. Then this becomes sine B plus C by 2 is equal to sine 180 by 2 minus A by 2. So now this 2 ones are 2 90s are. Then we get sine B plus C by 2 is equal to sine 90 minus A by 2. So what is, as we know, sine 90 minus theta is equal to cos theta, or cos whatever is there, consider this as cos. Then sine 90 minus A by 2 will become cos A by 2. This is the solution. See here, sine B plus C by 2 is equal to cos A by 2. Now next question is, express sine 67 degree plus cos 75 degree in terms of trigonometric ratios of angle between 0 and 45 degrees. Now given is sine 67 degree plus cos 75 degrees. Now first we will take sine 67 degrees can be written as sine of 90 minus 23, which is equal to cos 23. As we know, sine 90 minus theta is equal to cos theta. So this is first one. Then next, cos 75 degrees. Cos 75 degrees can be written as cos 90 minus 15 degrees, which is equal to sine 15 degrees. So we know that cos 90 minus theta is equal to sine theta. Therefore sine 67 degrees plus cos 75 degrees is equal to, now just we have to write here cos 23 degrees plus what we are getting here, sine So angle between we have to write in the form of 0 to 45 degrees. So this is C23 and this is, so since it is greater than 45, 0 to 45, this is 67 and 75, we have to decrease it to less than 45. So now we get sine 15 degrees. That's all. This is G. We have to just decrease the degrees and write. So this is the solution for the question 7, and this completes the exercise 11.3. So we'll start the new exercise, that is the 11.4. So first question is express the trigonometric ratios in sin A, secant A, tan A in terms of cot. So expressing all, that is sin, secant, tan in terms of cot. So first one will take sin A. Sin A will express in terms of cot. So sin A can be written as 1 by cosecant A. So cosecant can be written as 1 by square root of 1 plus cot square A. So we know that cosecant square A is equal to 1 plus cot square A. Cosecant A is 1 plus cot square A. Then cosecant A is equal to square root of 1 plus cot square A. So that's all. This is the solution. Sin A is equal to 1 by cosecant A. Cosecant can be written as 1 by square root of 1 plus cot square A. So now we finished this one. Then second one is tan A. Tan A is 1 by tan A is equal to 1 by cot A. That's all. Cot A. We know that tan A into cot A is equal to 1. Then we can write it as C here. Tan A is equal to 1 by cot. So third one is what secant A is also that. Secant A is equal to, we can write it as 1 plus tan square A. So all these should be in the form of cot. So we know that secant square A is equal to 1 plus tan square A, where secant A is equal to square root of 1 plus tan square A. So now we have to convert this into again in the cot form. Still we have not got in the cot form. So again we know that what tan A is equal to 1 by cot A. All these things we know. So now we have to substitute. As equal to secant A is 1 plus 1 by cot square A. Since there is 1 plus tan square A, tan square is equal to cot square. Then Simplify inside the square bracket, cross multiply. This is cot square A plus 1 by cot square A, which is equal to square root of cot cancels, or you can write it as 1 plus cot square A by cot square A. And if we remove this here, we can cancel this square root and write the square root only for the numerator. 1 plus cot square A by cot A. Cot A means this square root cancels, this cancel. Therefore, this is the solution. So if anything is there, for example, consider A. If we have A, there is square root is there. Cancel, this is equal to A. The answer will be A. So that is we applied here. So this completes the first question. We move on to the second one. So second one is write all the other trigonometric ratio of angle A in terms of secant A. So write down all the other trigonometric ratio of angle A or in terms of secant A. So first we know that sine square A plus cos square A is equal to 1. So sine square A plus cos square A is equal to 1. So sine square A is equal to this one, 1 minus cos square A we can write, which is equal to, so all we have to write in the secant form. So first we have taken this. So 1 minus 1 by cos can be written as 1 by secant square A. Secant square A. Then cross multiply here. Secant square A minus 1 by secant square A. Again same thing as we did in the previous problem. Remove the square root in the denominator. This will be secant square A minus 1 by secant A. So this is the solution. Now we'll take the second one, cos A. Cos A is equal to 1 by secant A. That's all. Now third one is secant square minus secant square A minus tan square A is equal to 1. Now again tan square A can be written as secant square A minus 1. So tan A is equal to root secant square A minus 1. Same thing, square here means we apply square root on both the sides. This cancel, square root cancel. Then here we'll get the square root. Or apply square root on both sides. So applying both sides, so I will just write down tan square A, then see this one. Then for this secant square A minus 1, write square root. Here square is there, square and square root cancels. Then you will get back this. So after this, then fourth one is cot A is equal to 1 by tan A. So now this we have to write in the secant form is equal to 1 by square root of secant square A minus 1 that is from 3 we can write. After this we have the fifth one, cosecant A. Cosecant A is equal to 1 by sin A. Now we have to write this one also in the secant form. So sin A we have here from 1 C, from the equation 1 or from the solution 1, sin A will be this one. So apply for sin here. Here also see we have applied square root on both the side. Then this will become, after applying, this will become sin A. The square root is applied, so on the both the side this will be sin A. So I have written here this sin A, substitute here. So then we can write it as from 1. So I will write in here root secant square minus 1 by secant A from 1. After this goes to the numerator. So now we can write it as secant A by square root of, this goes to denominator and this go to numerator, and denominator remains as it is, secant square A minus 1. So this is the solution for the second question. So we'll see what is the third one. Third question is evaluate sin square 63 degree plus sin square 27 degree cos square 17 degrees plus cos square 73 degrees. Therefore write down this sin square 63 degrees as it is, plus this one can be written as sin square 90 minus 63. So next cos square 17 degrees plus cos square 90 minus 17 degrees, which is equal to sin square 63 degrees plus this sin square 90 minus 63 can be written as cos square 63 degrees. Similarly this one write as it is, cos square 17 degrees plus, so just bring it to this form, that's all. Here 63 degrees there, just bring it to 63 degree. 17 is there, just bring it to 17, that's all. Minus this is plus sin square 17 degrees. That's all the solution. So as we know, so finally we can write this one as sin square plus cos square, as we know. See here, sin square 63 or sin square A or sin square theta plus cos square theta is equal to 1. So apply this here. One more thing, sin 90 minus theta is equal to cos theta and all these we have applied here. Cos 90 minus theta is equal to sin theta. All this we have applied. Finally, this will become 1. In the numerator also sin square 63 degree plus cos square 63 degree is 1. Then here also cos square 17 degree, sin square 17 degree, 1, 1. Finally 1, 1, the answer is 1. That's all. This is how to evaluate. Now next is sin 25 degree cos 65 degree plus cos 25 degree sin 65 degrees. Same thing here, sin 25 degree is cos 65 can be written as 90 minus, means we have to bring it to this form, minus 25 degrees plus cos 25 degrees, same thing here also, sin 90 minus 25 degrees. Similarly, all these things I have written here, just apply here. So what happens, this, write down sin 25 degrees as it is, then cos 90 minus 25 will become sin 25 degree plus cos 25 degree sin 90 minus 25 is cos 25 degrees is equal to sin square, this 2 is cos square, multiply this 2 and this 2, we'll get sin square 25 degrees here plus cos square 25 degrees. Finally add these two. As we know, sin square theta plus cos square theta is equal to 1. So this is the solution for the question 3, evaluating both. So we move to the question 4. So question 4, choose the correct option, justify your choice. So we have to justify it, and so we'll see the first one. First one is 9 secant square minus tan square is equal to, 4 options are given. So we'll take this 9 secant square A minus 9 tan square A is, secant can be written as, take 9 common, then secant square A minus tan square A. So we have this one, that is secant square A minus tan square A is equal to 1. So substitute here, that is 9 into 1 will be 9. So option B is the correct answer. So now next, second one, 1 plus tan theta plus secant theta plus secant theta, 1 plus cot theta minus cosecant theta. So here we can write it as, directly write 1, tan can be written as sin theta by cos theta, and secant theta can be written as 1 by cos theta. Again 1 plus cot theta can be written as cos theta by sin theta. Cosecant theta is minus 1 by sin theta. So now everything we know, that is tan theta is equal to, I will just write sin theta by cos theta. and secant theta is equal to 1 by cos theta, and cot theta is equal to cos theta by sin theta, and cosecant theta is equal to 1 by sin theta. So these are apply here. After this, cross multiply. Here cos is common, so take the denominator or LCM. Cos theta plus sin theta plus 1 will get by cos theta. Here sin theta is common, take LCM. Sin theta plus cos theta minus 1 by sin theta. So next is multiply this. This can be written as here, that is a minus b, a plus b into a minus b is equal to a square minus b square. Apply this here, then we get cos theta plus sin theta the whole square minus 1 square, a square minus b square by cos theta and sin theta, right as it is. After this, apply here for this part, just apply a plus b whole square, that is a square plus b square, a square plus 2ab plus b square. So apply here for this part. What happens now? Cos square theta plus 2 cos theta sin theta plus sin square theta plus 1 divided by cos theta into sin theta. Now what happens? Cos square theta and sin square theta is equal to 1. So I will directly write these two equal to 1 plus 2 cos theta into sin theta minus 1. Minus 1 is there, just write minus 1 here. Minus 1 by cos theta into sin theta. Cos theta into sin theta. Now what are cancels? This plus or minus cancels. Here cos theta cancels. Sin theta cancels. Finally we will get the answer as 2. So this is the solution for the fourth question, first two problems. We'll continue the remaining in the next class. So if you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.